everyone for coming out and listening to us talk today. My name is Cullen White. I ran this project, and helping me present today is Trey and Brandon. They played a big role in helping me collect data over the summer. And as was already said, we're going to be talking about eastern large beetle mortality in Tamarack stands. Now, obviously, Tamarack trees are a pretty big part of our research project. They're also known as the eastern larch. Scientific name is Larix laricina, and they are a deciduous gymnosperm, which means that they are basically a pine tree that's going to shed their needles every single year, which is something that's pretty unique in the pine tree world. And they're found in the Midwest, at least in the lowland, nutrient-poor, boggy ecosystems. And they play a pretty big role in helping support these ecosystems. For example, their pine cones are eaten by a variety of different small mammals, such as mice, squirrels, and rabbits. All these mammals are known as primary consumers, and they're going to draw in predators, which will help bring diversity to these stands from a wildlife standpoint. Neotropical migratory birds will come into these stands during the migration, and they'll take shelter in these stands, and they'll also eat the tamarack seeds. And the branches are actually used for nesting for different birds of prey, such as the great gray owl and the American osprey. And these lowland boggy ecosystems where tamaracks live host a variety of different amphibian species, like frogs and salamanders. This is actually the blue-spotted salamander that we saw when we were collecting our data this summer. So that's pretty cool. And so just to reiterate, these trees, they play a pretty big role in the upkeep of the ecosystems that they're found in. But unfortunately, in the last 20 years or so, we've been noticing a pretty rapid decline of the tree health. And in Wisconsin alone, there's been thousands upon thousands of acres of tamaracks that have been seeing newfound mortality. And the culprit behind this, the majority of this mortality, is the eastern larch beetle. Now, this beetle, it's coexisted with tamaracks for centuries. They've co-evolved around one another. And it's important to note that this beetle only attacks tamarack trees, and it's known as a bark beetle. So what they do is they're going to go in the trees and they're going to burrow into the phloem for food, and they lay eggs in the tree's phloem. That larva will hatch and continue to burrow in the tree's phloem, and that'll cause damage to the tree's phloem, obviously. And the damage, it'll usually only kill trees that are already under a high amount of stress, but in the last 20 years or so, we've been seeing that the populations of these beetles has actually increased to the point where they're able to kill these seemingly healthy tamarack stands, and they're able to kill them at a pretty alarming rate. So we know that a lot of these stands are dying, but there's still some of these stands that are surviving. So for our project, we kind of wanted to find out why some of these stands were experiencing mortality while the others were seemingly doing just fine. So we wanted to take a look and see if these beetles were following trends of other bark beetles, in that they're going to attack stands with a higher basal area, which is kind of, for our study, just correlated to the density. We figured that stands that had a higher density are more likely to experience that mortality, as in denser stands, the individual trees are under a lot more stress initially, as they're all competing for nutrients and resources with the other trees. And also, a higher density will have more stagnant air, meaning that less wind is getting into these stands, which creates a more suitable microclimate for the beetles because they prefer a more stagnant climate. They don't like getting bullied by the wind. We also thought that trees that had a higher DBH might be more susceptible to this mortality, as trees with a larger DBH tend to have more phloem in them, which the beetles use for food. And the larger DBH trees are able to insulate the beetles better during the winter, which will help them survive a harsher winter temperature. And we also wanted to take a look at the understory of these stands to see what might be possibly replacing them in the future, which has a variety of different management implications.
So yeah, for our research location, we chose UWSP Tree Haven. More specifically, that's located in the northeast corner of Lincoln County, shown on the map here. And within that 1,200 acre property Tree Haven, we have the units 153, 112, 111, all the units that we researched are highlighted in the blue outline here on this map.
So once we got to the site, we first began marking the plot center. Using a 10 VAF prism, we began spinning the plot and delineating which trees were in or out. This is a good example of what an in tree would look like. Once we calculated the trees that were in, the ones that were alive, we took note of the species and the DBH. And for the dead tamaracks, we would note the decay class and put the DBH as well. And this is what we used to get the DBH. Once we were done doing the bigger plot size, the bigger plot, we began doing a regeneration survey, which used the same plot center, but it was a 1/100th acre plot. We had 4 size categories, and we used a dot tally to count how many species were in each size category.
So after we got done collecting all the data, we ran some simplistic regressions, and we found that Tamarack stands that had larger DBH trees were more likely to experience that mortality that's statistically significant as indicated by our p-value, which is below that 0.05 threshold, meaning that it is statistically significant. But we do have a low R-squared value, which means that our data does have a good amount of variability in it, which is important to keep in mind. So just to reiterate, as those trees are getting larger, they are more likely to experience that mortality. And we found a similar result with the basal area of these stands, in that we had a statistically significant p-value, but a low R-squared value, meaning that we know with statistical significance, as the basal area increases, or in other words, as the density of these stands increases, they are more likely to experience that mortality. However, with a low R-squared value, there is still a lot of variability with our data. Moving on to the regen and the high mortality stands, we can see that Tamarack still made up a decent slice of that pie, with other species like tag alder, balsam fir, and black spruce making an appearance. And then a large majority of that regen was actually the red maple. The low mortality regen, or in other words, the stands that didn't have as many tamaracks that were dying in them, had a similar trend where the tamaracks made up a decent chunk of that pie. And the other species like tag alder, balsam fir, and black spruce making an appearance as well. We also had a lot of beech hazelnut in these low mortality regen stands that we surveyed, but the red maple still makes up the most out of any tree species. So just taking a look at those pie charts, you might think, okay, the future of these stands is going to be red maple then, because they make up so much of that regen. But this is not the case. As you can see, the majority of our regen fell in that 0 to 1 foot size category. And as the height classes of the regen surveys increased, the red maples dropped off pretty significantly. And I can tell you, out of all the plots we took, we only surveyed 1 red maple that fell within our plot, and that was just a singular 10-inch DBH red maple that was close to plot center. So they're able to get in these stands, which makes sense because in Tree Haven, there's red maple all over the place. And since the tamarack bogs are found in the lowland areas, the red maple seeds, which are dispersed by the wind, they're able to collect themselves in these stands, and they're able to seed out to become these seedlings and saplings, but they just don't have the resources they need to actually become a dominant tree species within these stands. Moving on to the tamarack, we found that a lot of the regen was actually in that 5 foot plus category, which is good news, as those individual trees, as they get larger, they're becoming more established and they're more likely to actually become healthier adult trees. And according to the Wisconsin DNR Reforestation Guide, you want roughly about 600 seedlings per acre in order to reforest a tamarack stand. And as you can see in our high mortality stands, or the stands with a lot of tamarack death, we got just shy of double that number at about 11,000 stems per acre. And even the low mortality stands, or the stands that didn't have a lot of tamarack death within them, still had that, they still met that threshold at about 630 stems per acre, which means that the tamaracks in the site we found are able to seed themselves out. So this is good news. Now it is worth noting that for our research, we did it in the small area for a research basis. It was just that Tree Haven site. So all the data that we found is really only applicable to that site at Tree Haven. But it would be worth it to continue to monitor these stands and start looking at other forests adjacent to that site and start going into neighboring counties just to get a better idea of what the trees, the Tamarack trees in Wisconsin the trends are following as a whole. See if they're following our trends or if there's new trends that they're following. It'd also be worth it to look at other factors other than the basal area and the DBH of these individual trees to see if there's something else that's highly correlated with whether those beetles are able to kill the trees or not, and possibly increase our R-squared value, which would in turn mean that there's less variability within our data. But as long as they're able to seed themselves out at Tree Haven, there's no real management implications we need to be taking at this time. It would be worth it to continue monitoring these stands and making sure that they're able to seed themselves out at an acceptable rate. But as long as we don't let this eastern marsh beetle infestation go unchecked and we keep monitoring it, if we don't do that, then these trees can experience even more mortality than they've already been experiencing, and in turn that will cause detrimental damage to the ecosystems that they're a part of. And so we're gonna turn this over to you guys for questions, but before we do, I would like to acknowledge some people for helping me with this research project. First and foremost, Trey and Brandon, as I already said, they helped me collect data over the summer. They were there with me every single day collecting the data, as well as some other UWSP students. I'd really like to thank them. My advisor, Eli, he was with us every single step of the way. He gave us equipment, gave us access to the Tree Haven property to do the research, and he was a great resource to have. He really helped me with this research project, and I definitely could not have done it without him. And then all the UWSP faculty that I consulted with helped me make this presentation, helped me make the graphs. They were also a huge asset to have, and I'd really like to thank all of them. But without further ado, I'll turn this time over to you guys to answer any questions you guys might have.